Hello everyone, welcome to the solution of LeetCode problem 680 named valid palindrome true. In this problem, we are given a string s and we have to return true if s can be palindrome after deleting at most one character from it. That means we can delete at most one character, which is we can delete 0 character or 1 character from the string. And after that, we have to determine the resultant string will be palindrome or not. Suppose in the first example, ABA, it is palindrome by default because if I read it from the forward or backward, it will be ABA. That's why in this case, we are deleting 0 characters. Now, in the second example, ABCA is a palindrome if we remove the character C. If we remove the character C, it will become ABA, which is a palindrome. That's why you have to return true. But ABC can never become palindrome after removing at most one character. So in this case, we have to return false. Here, the constraints are the length of the S can be in between 1 to 10 to the power 5. And each of the character in S is the lowercase English letters. I hope you understood the problem. Now let's move on to the algorithm. Before starting the analysis of the algorithm, at first check how to determine a string is palindrome or not. We can determine the palindromic property of a string by using two-pointer approach. Here, at first, we will mark the first character of the string as the first pointer, which is a start, and we will mark the last character of the string will be another pointer named end pointer. Now, in each iteration, we will update the start pointer and the end pointer and check whether the value of the start pointer and the end pointer are equal or not. Suppose here, the start pointer value is A and the end pointer value is A. So both of them are equal. So in this case, we should update the start pointer. Now our start pointer is pointing to this B and our ending pointer is pointing to this B. And here, both of these B are equal. So now, this is the main strategy to determine whether a string is palindrome or not. If in any iteration, the value of the start pointer is not equal to the value of the end pointer, then we can say that this string is not palindrome. Otherwise, if the value of the start pointer is equal to the value of end pointer in all of the iteration, then we can say that the string is palindrome. I hope you understood what is the main criteria to determine a string is palindrome or not. Now let's solve this main problem. Suppose this is the input string given. Now here, at first our start pointer is pointing this first character A and our ending pointer is pointing this last character A. So here we can see that both of them are equal. Now our start pointer is pointing to this B and our ending pointer is pointing to this B. But both of them are equal. So now our start pointer is pointing to this C and our ending pointer is pointing to this D. But wait, the value C and the value D is not equal. So here, according to the problem statement, we can skip at most one character. That means either I can skip C and move to the start pointer to this D, or I can skip this D and move to the ending pointer, this A, and continue the iteration. Now, as suppose we have two choices. Either I can remove this or I can remove this. Suppose if I remove this C, then this portion of the string should be palindrome. This is one case. Another is that suppose I am discarding this D. Now, if I discard this D, so this portion of the string should be palindrome. If any of this portion of the string is palindrome, that means we have to return true. That means by deleting at most one character, we have found that the string can become the palindrome. So this is the main algorithm. Now I can summarize. In each iteration, if I found that the left pointer value is not equal to the right pointer value, that means in those positions, I have two choices. Either I can discard the left pointer value or I can discard the right pointer value. If I discard the left pointer value, that means this portion of this string should become palindrome. Or if I remove the right pointer value, that means this portion of the string should be palindrome. If any of this portion of this string is palindrome, that means we have to return true. Otherwise, we have to return false. This is the basic algorithm. Now let's move to the code. In this problem, the code is pretty simple. At first, we are given a function named valid palindrome. The input of this function is string s. Now, we are taking two pointers, which is left and right. The left is pointing to 0, and the right is pointing to the last character of the string. Now, we are using a loop. In each iteration, we will check whether the left pointer is before the right pointer is or not. If the value presented in the left pointer is not equal to the value presented in the right pointer, that means in these positions, I have two choices. Either I can discard the left pointer value or I can discard the right pointer value. Now, if I discard the left pointer value, the positions left plus 1 to right should be palindrome. And if I discard the right pointer value, the position left to right minus 1 of this string should be palindrome. After that, if the value presented in the left pointer and the right pointer is equal, then we have to upgrade the left and right pointers. So finally, we have to return true. Now, inside this palindrome checking function, we will run a loop, and here in each iterations where the left value is less than is equal to right value, we will check whether the value presented at the left position is not equal to the value presented in the right positions. If both of them are not equal, that means it will never be possible for this string to become palindrome. That's why you have to return false. Otherwise, if both of the value are equal, that means we have to upgrade our pointer value. And finally, after iterating all of this string value, it did not return false. That means we have to return true. I hope you understood the code. Now let's move on to the time and space complexity analysis of this program. In this program, the time complexity is big O of n because we are iterating each of the characters of the string. And the space complexity is big O of 1 because we are using only one extra memory to store the pointer value. So here, the time complexity is big O of n and the space complexity is big O of 1. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.